Oops.
Oh, good afternoon on this cold winter's afternoon here in Corpus Christi. We're going to look at rational and radical equations today. First of all, rational equations. A rational number is any number that can be written as a fraction, one integer over another integer. So, a rational number is really just a fraction. A rational equation is an equation that contains fractions. And I recall that at the end of class the last time we looked at an equation with that had fractions in it. And we used that idea of multiplying through by the least common denominator to cancel out the fractions. Well, the difference here is these fractions are going to have denominators in the variables. Variables in the denominators. I said it reversed. Variables in the denominators. Is this microphone working? I don't hear it. Am I coming out through the speakers? Yeah, over there in the peanut gallery? Yes, y'all hear me? Okay. Now, there is a wrinkle in this idea of multiplying through and eliminating the fractions. You start off with an equation that contains a fraction. You end up solving an equation that doesn't have a fraction. So, with that in mind, when is a fraction undefined? Fractions aren't always defined. When is a fraction undefined? Think about the definition of division. When you were first learning how to divide, you would have learned multiplication first. You would have said that, your teacher would have said, 8 divided by 2, I'm using a fraction bar to represent division, but your teacher would have said 8 divided by 2 is equal to 4, because 4 times 2 is equal to 8. 4 times 2 is equal to 8. That's just the basic definition of real number division. The quotient times the divisor gives you the dividend. Well, suppose we'd had something like 8 divided by 0. So, remember the quotient times the divisor has to give you a dividend. What number times 0 is going to give us 8? Nothing, because if you multiply by 0, if you multiply anything by 0, you're going to still get 0. You're not going to get that number 8. So we'll say that 8 divided by 0 equals nothing. Division by 0 is undefined. What about this? 0 divided by 0. Realize a quotient is unique. 8 divided by 2 is equal to 4. There's not another number that you can multiply by 2 to give you 8. Well, what about 0 divided by 0?
What
Times 0 will give you 0. 0 times 0, yeah. Is there another one?
1
1
times 0. Any number.
Anything. So, 0 divided by 0 is also undefined because it doesn't give you a unique answer. So, any number divided by 0, whether it's a 0 or some number other than 0, a numerator divided by 0, N-O, what does that spell? No, that can't be done. We say that's undefined.
The way your calculator or this calculator does it, it gives an error warning. 8 divided by 0, error, divide by 0, okay? So, while I'm thinking about it, suppose we have the 0 on top and something other than 0 on the bottom. Suppose we have 0 divided by some non-zero constant k. 0 divided by k, that says okay, that's equal to 0. The only time you can't have a 0 in the numerator is if
you have a 0 in the denominator as well. The main thing you need to remember is that you cannot have a denominator equal to 0.
It really doesn't matter what's on top.
Yeah, it doesn't matter.
Zero's in the bottom, it's undefined. Even on a calculator, 0 divided by 0. I remember years ago, a math teacher writing to TI, or telling me he was going to write to TI. It wasn't at this school, because the calculator gave an error whenever they entered 0 divided by 0, and he knew anything over itself was 1. I'm sure you've heard that. Anything over itself is 1.
Not 0 over 0.
Except for 0 over 0. 0 over 0 is not 1. TI is not making a mistake when they say error, divide by 0. Okay?
Fractions are undefined when the denominator is equal to 0. Tony, could you dim the lights a little bit?
Yeah.
The display seems so
Are you
pale.
ready to solve it? Okay.
So the first couple of problems in this assignment, they're just giving you equations, and they ask you what values of the variable cannot possibly be solutions for the given equation. You don't have to solve the equation. I think a little brighter than that. Right? Okay. Is that okay, y'all? Yes, you can see what you're writing? Okay. They're not asking you to solve this first equation. All they want to know is what numbers could possibly be solutions. Well, those are the numbers that would make the fraction undefined. So let me write the problem down. 5 over 2x plus 3 minus 1 over x minus 2 is equal to 0. When is a fraction undefined? It's switch over to my paper. It's undefined when the denominator is equal to 0. Here there are two separate denominators. We don't want either of those denominators to be 0. We don't want 2x plus 3. That shouldn't equal 0. And x minus 2 shouldn't equal 0. So that will not equal to, we'll just work with it as if it were an equal sign. Let's solve this one first. That's the easiest one. Getting x by itself, we'll have x cannot equal. Move the 2 over, I agree. So there's the one number. Now, if you solve this equation, you better not get 2. 2 would not be an acceptable solution. And the next one, let's solve this one for x. What will I do first?
And when you say solve, it's the same thing as solving for x.
Yes.
Okay?
Let's solve for whatever variable appears. Okay, so that's going to give us 2x can't equal here negative 3. And then what do we do?
Divide by 2.
Okay. So x shouldn't equal negative 3 over 2. So here are two numbers that x definitely can never equal. If we solved this equation and got 50 million, that'd be fine. The only numbers that would be unacceptable are 2 and negative 3/2. Any questions there? For these first two problems, all they want to know is what numbers make the fraction or not solutions.
So that's how you would solve it to get
That's not, we're not solving the equation, but that's
Yes, but
Yes.
you would have to solve it. But it's possible when you start solving these things to end up with no solution.
if you went through and solved by multiplying through by denominators, eliminating fractions, say you wound up with 2 as the solution, you'd have to cross it out, and that will happen. As we go through the homework, we'll solve an equation and we'll get a number that when you plug it in at the end, it'll give us a denominator of 0. I know that happens. It always does.
Okay, so negative 3 over 2.
Get out of that
Okay,
denominator.
don't do this. You see that second number 2 should not be down there in the denominator of the fraction. So let me back up. Oh, 2, right arrow, comma, 2.
All they're looking for in these first two questions are numbers that cannot be
Answers. The ones that give you 0 in the bottom.
number 2. I'm going to write small.
Number 2 looks much harder than it is. Decide what values of the variable cannot possibly be solutions. Do not solve. You're not solving yet. If you were going to guess solutions, there's 2 numbers you should definitely not guess.
Those are the numbers you shouldn't guess are the numbers that give you a denominator of 0. Just looking at this first denominator, what number would give us a denominator of 0 there?
2?
Hold on.
Well, let me do this.
There. Okay, so the first denominator, x minus 2, that shouldn't equal 0. So x shouldn't equal, and I heard it, 2. You move that negative 2 over, it becomes a positive 2. So there's one answer. X can't possibly equal 2. Now the next one. X plus 3 can't equal 0. So x cannot equal negative 3. You move the 3 over, you undo the plus 3 by subtracting 3. Oh, there's a third denominator. This third denominator.
Which one of the denominators looks the messiest?
Denominator 1, 2, or 3? 3.
Why?
Well,
because of the x squared?
Yeah, but
let's try solving by factoring. If we try to factor x squared plus x minus 6, I'm not going to, if I can't get it factored, I'll go to the quadratic formula, but I think we can factor this. X squared,
X and X.
x times x, and for 6, 1 times 6 or 2 times 3, remember it's a simple trinomial, so the pair you choose
Need to subtract.
to give you what?
x plus 3 and x minus 2.
Okay, well, a plus 3
Oh,
and a
she's
minus
already
2, that does it. Haven't we already set those things equal to 0? X plus 3 and x minus 2. This denominator factors as those two denominators, so we're not going to get any more numbers. The only numbers we have to discard are 2 and negative 3. The whole point of these first two problems is to make sure you're aware that you have to discard solutions that give a denominator of 0. And it doesn't matter what the numerator is. Suppose number 2 had looked like this. Suppose that top had been 11x minus 5.
That changes
Nothing. To determine when a fraction is undefined, the only thing you look at is the denominator. This thing here, if this numerator appeared being 4x minus 7, that still would not change the answers. Numerators have no impact on determining when a fraction is undefined, only the denominators. So punching in, we'd have to exclude 2 and negative 3.
What would the final answer be for that last part? Because the x plus, it was just...
Oh,
You'd get the same thing if you said x plus 3 not equal to 0. You get negative 3. Don't we already have it right there? And x minus 2, you'd get x equals positive 2. So we'd be getting the same numbers, negative 3 and positive 2. That's why I didn't go through and finish it off. As soon as I realized they were the same factors as earlier,
Now, if you're doing your homework, staying caught up and doing it, like today or tomorrow, then you might remember what I'm about to say. Everyone's number 2 works out like that. This third denominator is just the same as this times this. So we got 2 and negative 3. That was right. I'm going to say similar question. I'm not going to write this down, but I'm wondering if y'all can tell me the answers. What would make this one 0? The first denominator. Would 1 give it a 0 there? Okay. And what about this one here? Negative 3. I think I heard all of that a moment ago.
And if you factor that third denominator, you'd get it factored as x minus 1 times x plus 3, so you wouldn't get any more numbers to discard. All you get is 1 and negative 3.
But how do we actually solve one of these equations? That's what we're going to be doing on problems 3 through 7, showing you how to do it.
This is number 3.
When you write it down, sort of spread it out, because we're going to be multiplying through to get rid of the fractions.
I know, but still,
Slow it.
okay. Notice how I wrote the fractions spread out, because we're going to be multiplying through to get rid of the fractions. I'll be putting something there, and over here. Look at the denominators. You need to ask yourself, can the denominators be factored? Like on that number 2, that last denominator could be factored. Here, the denominator's a number. No, that's just a constant. That stays the same, okay? What about x minus 3? Can that be factored? No. If you're going to factor something, you shouldn't. Is it just going to be an x minus a number? If you're factoring, what do you have to see?
X squared.
Yeah, exponent. So x minus 3, we say that's a linear factor. It can't be factored any further. If you have denominators, different denominators that can't be factored, then the least common denominator is found by multiplying the 2 denominators. We have 2 distinct denominators, neither of which are factorable. The least common denominator is the product. The least common denominator, LCD is standard notation for least common denominator, will be 2 times x minus 3. Realize we're going to have to distribute that 2 times x minus 3 on the left side and the right side. Well, on the left side, I'm looking on the left side of the equal sign. How many distinct terms do I have here? 1 and 2. How many distinct terms do I have on the right side? 3. So I'm going to be multiplying. But that's the third one. 1, 2, and then there's the third term. 1 on the right-hand side. We'll multiply through. We're going to be distributing the 2 times x minus 3. And I like to put it over 1. 2 times x minus 3. And here I'll put the 2 times the x minus 3. No. Remember, you can cancel factors that are 1 in the numerator and 1 in the denominator. So when I'm looking at the first product, I cancel the 2. That's going to leave me. Now keep in mind, we're getting rid of the fractions. I didn't say it was going to give us something nice once you get rid of the fractions. It's just getting rid of the fractions. But look what this first term is going to become. It's x minus 3 times 2x plus 3. minus, this minus here is this minus right here. Look at that second product. What's going to cancel? The x minus 3, x minus 3. So we have a 2 times 3x. I can do that in my head. What's 2 times 3x? 6x, I agree. Equals, now, x times 2. X times 2, we know that that's the same thing as 2x. So you have 2x times x minus 3. Well, we're going to have to distribute there. 2x times x minus 3. Distribute, what's that going to give us? 2x squared minus 6x. Any questions on what we've done at this point? Because this is the real, right here, the way we've gone through eliminating the fractions.
So how did you get the 2x, that one, the very end?
This one here, x times 2, it's the same thing as 2x. A times b is the same thing as b times a. Generally, a variable times a number, you write the number first. The number is the coefficient.
So you multiplied it by, still by the 2x minus 3?
Then I had to go through, I had 2x, this is 2x times x minus 3, I distributed. 2x times x, and 2x times a minus 3 gives us a minus 6x.
This is some messy manipulation here.
And it's going to get messier.
Oh, Tim, you're such a opt.
Any questions before we go on? Okay, I see an x squared, so I'm thinking it's going to be quadratic, but if it's quadratic, we have to get the thing set equal to 0 and combine like terms. We're going to have to multiply this stuff out here. Binomial times a binomial. What are we going to do to perform that multiplication? Foiling out, so here goes. First,
Maybe the light is too bright because it gets brighter.
okay, first, 2x squared, I agree, x times 2x, outer, x times a positive 3. Okay, so plus 3x. What about inner? Negative 3 times a positive 2x. Negative 6x. Negative 3 times positive 3 is?
Negative 9.
And we still have that minus 6x there. Equals 2x squared minus 6x. Let's combine like terms now. Let's just work here on the left side for the time being. We have a 2x squared. Combine 3x minus 6x, that is negative 3x minus an additional 6x, negative 9x, I agree. And what else do I still have on the left side? That minus 9 right there. And I said earlier, it looked like it was going to be quadratic. We need to get it set equal to 0 and solve either by factoring or the quadratic formula. But I don't think so. Let's start trying to combine like terms. Let's take this 2x, the 2x squared, and try to move it over there and combine it with this term here. What would I have to do to both sides? Subtract 2x squared. Look at what we're getting. What's about to happen to the square terms? They're canceling out. 2x squared minus 2x squared. So for this first equation, we don't have to worry about factoring. or the quadratic formula. The result's going to be linear. We have a negative 6x over here. Okay, let's add the 6x, add the 6x, negative 9x plus 6x, that's giving me a negative 3x. I still have what on the left side? Minus 9. And over here on the right, what do I have? 0. We need to solve for x. This is linear. We're trying to isolate x. So what am I going to do with this constant term? Add 9. That'll give me a negative 3x is equal to a positive 9.
Wait, why are we adding 9?
How do you solve a linear equation? You isolate the variable. The first thing you do, you undo the addition and the subtraction by performing the opposite operation. The opposite of minus 9 is a positive 9. And then what are we going to do? To give us 9 divided by negative 3 gives me negative 3. Well, I was about to box that in, but look back at the original problem. Let's look back.
Notice, one of the options is the empty set. That's how they're saying no solution. Well, when would no solution happen? Well,
look at those denominators. Remember what we said about fractions. When a fraction's undefined, look at that first denominator. Is that thing ever going to be 0? No, that's a constant. What number would be unacceptable for x? 3?
a positive 3.
That denominator can't be 0, so we better not have gotten a positive 3. What did we just get here?
Negative 3?
I was thinking it was going to be a positive 3. Okay, that's why I was thinking it wasn't. It's so messy up here, I can't really tell what I had written there. So I was thinking this was going to be crossed out. But no, negative 3 is acceptable.
Which means
We come over here. Now, if we had gone through the process and we'd wound up with the number that gave a denominator of 0, that's when we would have chosen option B. The solution set is empty.
eliminating those fractions can be sort of messy.
And this one here is very important because it illustrated the fact that if you have distinct denominators that can't be factored, the least common denominator, the thing you have to multiply by, is the product of those denominators.
What's the next one going to illustrate?
Oh, well.
Okay, number 4.
I bet y'all will be able to tell me that. What are we going to have to multiply 3 by here? Remember, I'm going to write this skipping space because I want to have room to stick that LCD in front of every term.
But the least common denominator is
If there's only one denominator, that has to be the least common denominator. I claim we only have one denominator here. What is it?
well, no, I was just looking back at the other one
Oh.
and how it was 2x minus 3, but I'm like wondering now, is it just because it was the first one?
I didn't understand your question. Can you repeat it?
The least common denominator, how did you find that?
I looked at the two denominators that appeared, asked myself, could either of them be factored? They couldn't be, in which case then the least common denominator is just their product.
Just the two denominators.
2 was the first denominator times x minus 3 was the second denominator.
It's just the two denominators.
You want to cancel out the 2, you want to cancel out the x minus 3, so you got to have a 2 in that LCD on number 3, and you got to have a x minus 3 also to cancel out both of the denominators.
You have two separate, completely different denominators. Those are the common denominators.
The product is the common denominator. Now looking at number 4. What are we going to multiply 3 by to eliminate those fractions? There's only one, well, it appears twice. The denominator appears twice, but I claim there's only one denominator. What is it? X minus 4, that's what you're going to multiply by. Multiply through by x minus 4. While we're thinking about it, what cannot be x? What number would be unacceptable for x? If we go through this and get that number, we're going to have to cross it out. 4. You can't allow that denominator to be 0. And so let's just make a little note over here. X minus 4 can't be 0. That means x cannot equal positive 4. That way, once we're through solving it, we can look back up here and make sure we don't get 4.
And if you do, then it's not statement.
Then
let's see
there's
how
no solution.
The
then.
solution is the empty set.
Well, maybe we'll get 2 possible
yeah,
solutions.
we might get 2 solutions. So.
That's one of the possibilities. We may get 2 solutions. One of them's 4 and one of them's something else. Then you have to cross out the 4 and keep the other one. Oh, and switch back. I want to make a note of something. The first fraction is one term. The second fraction is another term. And that plus 5 is the third term. Those fractions, those terms are separated by plus, minuses, and equal signs, okay? And a fraction by itself is an individual term. So that means we're multiplying by x minus 4 3 different times. And you'll notice that's what I did here. X minus 4, x minus 4, x minus 4. This is going to work out nicer than the first one, I think. Here, what's about to happen? So all we're left with, x equals, what's going to cancel here? The x minus 4, and we're left with, 4 divided by 1 is just 4. What's going to cancel here? Nothing, because there's no fraction. What are you going to have to do to multiply x minus 4 by 5? And that's going to give us
5x minus 20.
Okay. Once again, we don't have a square. Get all the x terms on one side. Get the constant terms on the other side and divide by the coefficient. I think I'll move this 5x over to the left by doing what? Now, I think I want to move the 5x over here and combine it with the 1x. And so what did y'all say do?
Yeah.
Subtract. Okay. We bring it, picking up the plus 5x, moving it over, it becomes a minus 5x. 1x minus 5x gives me negative 4x. Okay. Hey, what about 4 minus 20? We never combined those constant terms. 4 minus 20 gives me negative 16, and then that's going to give me x equals negative 16 divided by negative 4 gives me a positive 4. But don't box that in. Remember, what number did we say x could not equal?
4.
It couldn't equal 4. This number gives a denominator of 0. The denominator equals 0. We don't have another option here. So, we're going to have to select.
Solution is the empty set.
I would have written out no solution.
Yeah,
but
I would have preferred if it said no solution. But you know what? Let's just see what happens. Let's see how smart it is. If I put 4, is it just going to say wrong, or is it going to say, oh, wait a minute, you're almost right? No.
No.
All right. It's just going to
Some
one or
should-
more of your responses is incorrect. Okay.
Nothing vague about that.
No. So there. Empty set. Wow, think about that. Not a single number in the world will ever make this left side equal the right side.
You could
Maybe I'm
spend the
only
rest
one.
of your life. Your children could take up where you leave off, plugging in numbers there, and you will never find a number that makes the left side equal the right side.
Maybe I'm the only one that thinks that that's amazing.
I think it too. So maybe we're the only ones in these classrooms that think it's amazing, but anyway.
Okay, so if we have just the same denominator being repeated, that's the least common denominator. Multiply by that. If we have two distinct linear denominators, just multiply by those.
What happens if we have
And
repeated factors?
X squared and an X. What would we have to multiply by to get those two denominators to cancel?
Number 5. We still haven't gone to the store and bought a new tablet, although we know what kind we're going to buy, but still haven't gone to buy one. So I'm trying to get this assignment all done in one.
On one sheet of paper?
No, and this tablet, I don't have that many pages, so I'm trying to write small. Switch over. Hold on, let me move that out there.
Well,
We have repeated factors appearing. You say, well, no, yes, we do. We have the factor is x that's appearing in the denominator. We have an x squared and an x to the first power. The common mistake is for people, they see that and they think, oh, just use x. If I were to try to multiply here by x, would I cancel out that entire denominator? No, I'd only cancel out one x. I'd still have a denominator of x remaining. So here's the trick. When you have repeated factors appearing in denominators, for the least common denominator, use the larger exponent. Use x squared. And I forgot to ask y'all this, but how many times am I going to have to multiply by x squared?
1,
2, and then over here 3. Each fraction is a separate term. The 18 is a constant term. So we're multiplying by x squared 3 different times. Look at that first product. What's going to cancel out here? The x squared, so what are we going to be left with? Just a 3 minus here. What's going to cancel out? Okay, so we're going to lose one of those x's. We'll lose that x down there. What are we going to have left there in the middle? X times 53 is 53x. I agree. Equals, oh, this is nice. What have we got on the right side? 18x squared. Well, it's not that nice because the x squared isn't canceling out. We're going to have to solve this thing either by factoring or the quadratic formula. And I've noticed something through the years. If they don't say solve by the quadratic formula and the equation's quadratic, they're trying to tell you it's factorable. Now, this is one of those things I told you, those teachers that didn't want to use this program years ago. This is one of those things where I can't go in and say, oh, I'm going to do this problem and this problem and this problem and make sure I know how to work it just like that. Because every time it'll change. And so I can't prepare ahead, and say, oh, I'm going to work this problem out to make sure that I know how to factor it real easily, okay? Okay, but as I'm here talking to y'all, I see the factorization. I think I see it. If we're going to solve this by factoring, Oh, but if I can't get it factored quickly, I'm going to go to the quadratic formula. But this one I think I can get done pretty quickly. If we're solving by a factoring or the quadratic formula, what number do we need on one side? 0. And the number in front of x squared, what sort of a number do we want that to be?
Positive or negative?
So I'm leaving the 18x squared where it is. I'm going to move these terms over to the right and get 0 equals 18x squared. That minus 53x is going to become a
less.
Okay. What's going to happen when we move that 3 over? No, I agree. And 18 times 3 is 54. As I was up here talking to y'all about how to, sometimes I won't see the factorization, in which case I'll go to the quadratic formula. It's impossible as teachers to just prepare and know, oh, this is how that's going to work out. Because every time we can log in, the numbers are different. Just like with y'all, okay?
Well, I think the students, we have it set that for y'all, if you print it out, it should save those numbers until, but anyway.
Okay, so.
We're supposed to know how to do it already.
Yeah,
So
and I think I do. I'm not going to bother. I'm running out of room here. Now, for 18x squared, there's 1x times 18x. There's 2x times 9x. 3x times 6x. I know 3 and 6 can't work. Because, remember, you can't have a common factor inside parentheses. 3, there's only one possible pair. What is it? 1 times 3. If you use 3 and 6, you're going to wind up with a common factor inside the parentheses. In order to get all the problems done that I want to get done, I'm going to try to rush on the factoring. You can practice your factoring, but we're going to have to rush on this. I believe we need to use 1x and 18x. Because I noticed 3 times 18 is 54, and that middle number there is only 1 away. When that happens, that's what makes me think use the number that appears in the problem. And then for 3, let's try that 3 there and the 1 there. We can't put the 3 here. We can't put the 3 here because then 18 and 3 would have a common factor of 3. And so if we're going to use 1x and 18x, we better have it like that. And let's check. Let's make those little bars that Tony makes. 3 times 18x, that's a 54x. X times 1, that's a 1x. And what do we need? We need a positive 53x. That last sign's a minus, so what do we know about the signs? 1 positive and 1 negative, so start playing around. What are you going to have to do to get a positive 53x? I think you need the 54 to be positive. Okay, so a plus 3.
Oh, y'all have gotten good at this.
And a minus 1. That's a positive 54x minus 1x gives me a positive 53x. So, set each factor equal to 0. X plus 3 equals 0. That means x equals negative 3. That's the first one. And now the next one. That 18x minus 1 equals 0. What will I do first? To give us 18x equals 1. And then to give us x equals 1 over 18. Oh, I forgot to make a note. What's the only number that would give us a denominator of 0 in the original problem? It should be obvious.
It's so obvious it might be difficult. No. What about this one right here, where it's just an X?
Show it to them without all that writing. Show them
okay.
on my lab so they can see the
What's the only thing that would give us a 0? Do this one right here. 53 over what? Yeah,
Zero.
0.
X can't equal 0. We know that X can't be 0. Did we get 0 as an answer?
No.
No, we got -3 and 1/18. So both of those answers are okay. The only number that wouldn't have been okay was 0, and we didn't get 0.
-3 and was it 1 over 18?
Yes.
Is that what you said?
Any questions?
But
Okay.
X can't equal 0 because that's what we've been pulling it out to.
That'd be what gives you a
The
0 in the
denominator
bottom.
of 0.
Okay.
Okay. What number gives you a 0 in the bottom? Well, a 0. Okay. Okay. On this one over here, the one we did earlier,
What number gave us a 0 on the bottom? A 4.
if I could control the numbers, I wouldn't have had a 4 right here. There's too many 4s on problem 4.
Yeah.
Yeah. All right.
Any questions there?
So if there's an x squared and an x in the denominator, multiplied by which one? The
Even if it
bigger
had been,
exponent,
even
x
if it had been
squared.
an x minus 3 and an x minus 3 squared, if it's repeated factors, use the factor with the bigger exponent. Question.
Oh.
I thought I heard a
Your hand
question.
go up?
On the 0, it can or can't be from the denominator numerator.
The denominator can't be 0.
And we
So-
didn't get a 0. So these answers are okay. If I'd solved this thing and got an x equals 0, I would have had to mark it out.
I'm still lost on how you got the 0 though. Is that because
Okay, set the first. Okay, come over. Let me come right here.
See what we were doing on problem 1
So
and 2.
x squared can't equal 0, and x can't equal 0. The things that we're doing on 1 and 2, we take the denominator and say it can't equal 0. What number can you square to get 0?
That's the only number you can square to get
0. What about this one here? This one's already solved for x. What is it?
X can't be 0.
Okay,
Okay?
that makes sense.
Number 6. I was thinking I want to do number 7, which we don't have on any of the videos. I thought I would skip over this one, but then I decided against it because it illustrates something important that you would have seen in previous classes.
And that I use a lot when I'm doing stuff, especially the next. Oh no.
2x minus 6 over x is equal to x minus 4 over 2. I'm doing almost all the teaching today because, I was waiting for test results and I was a little nervous. And, you play that let's make a deal, silently you're like, oh, I'll do this. If the results come back and they're good,
You'll teach the class and I'll just sit there.
No,
I'll
I
teach
told,
it.
the deal was, I was like, you could just go, Tony. You
Oh.
can go off and do whatever you want to.
Oh, I'm going to
Okay.
sit right here and type in the answers.
Okay.
Now, number 6, what's unique about that is it's in the form fraction equals fraction.
But before we go on, I bet you could tell me the least common denominator. There are 2 distinct denominators. Can they be factored?
No.
No. So what did I say the product was? If you have the least common denominator is if you have 2 distinct denominators, or even 3, if you have distinct denominators, well, it'd be the product. X times 2, so 2x. I'm going to do something different, though. Let's switch over to my work. I'm not going to multiply by the least common denominator. In previous math classes, you would have seen expressions in the form fraction equals a fraction. That's called a proportion. There's a method of solving proportions that involves a special type of multiplication. Does anyone remember what that type of multiplication is?
Product of the means equals product of the extremes. I remember teachers saying that. Didn't know what the heck it meant, but I remember the teacher saying
Maybe
that years ago.
you can only do this if the equation's in the form fraction equals fraction. Does the phrase cross multiply sound familiar to you?
A little bit, yeah.
Rather than multiplying both sides by 2x, you get the same thing. But when you have a fraction equals a fraction, you can cross multiply. Numerator times denominator equals numerator times denominator. So we go.
And you do that when the denominators are different?
No,
Well,
you do
well-
it when it's fraction
On one side,
equals a fraction on the other side.
notice, no other problems have been in that form. Like number 5, it wasn't just one fraction equals a number. Okay?
Equals a fraction.
Equals a fraction. Here, if we didn't have the plus 5, it would be in the form fraction equals fraction. Okay, but because of that plus 5, no. With number 3, fraction equals fraction, no.
That makes sense.
So, to cross multiply, you multiply the 2x minus 6 times 2. I'll write it as 2 times 2x minus 6 equals, you multiply there, that's the x times x minus 4.
Wow. So, you didn't really save anything. You see, I would have just skipped that step and gone.
We're in a hurry, Tony. So taking time to tell me that.
Oh,
We're going to be here till 7 at this rate.
no, we won't.
Distributing the 2, we're getting.
4x minus 5.
Right. Here, distributing the x, we're going to get.
X squared minus 4x.
Okay. And it's quadratic, so we need to get it set equal to 0.
And 5x.
Okay, but where are we going to get the 0? On the right or on the left? What do you think? I'm going to get the 0 on the,
Left.
because I want that x squared. If I move that x squared over, it would become what? A negative. I don't want that. So I'll get the 0 on the left. Now the 0 equals, I have the x squared. Move the 4x over. Negative 4x minus 4x gives me
Negative 8x.
negative 8x. What else am I going to have over here?
Positive 12.
Okay. It's quadratic. And before we even finish, we can see that denominator there is never going to be 0. That denominator is 2. Period. What number would make this denominator equal 0? 0. So as long as we don't get 0, everything's fine. And I'm going to make a little note of that. X shouldn't equal 0. Okay? And, oh, I like this. Last sign's a plus, so what do we know about the signs?
So it's going to be a minus.
Okay, if the last sign's a plus, you're going to have 2 of those first signs. So we have a minus and a minus, x squared.
So 4 and 3.
Okay, well, for x squared, it's just going to be 1x and 1x. Now for 12, we have 1 times 12, 2 times 6, and 3 times 4. This is a simple trinomial. The leading coefficient is a 1, so choose the pair. In this case, it's going to add up to give us what? 8. I heard a 3 times 4, but I think it's going to have to be a 2 times 6, yes. And if you check the outer and the inner, negative 6x and a negative 2x, sure enough, that gives us a negative 8x. So we set x minus 2 equal to 0 and x minus 6 equal to 0. That says x equals here 2, okay. Here, okay. Any questions there? I know I'm going a little bit faster than I normally would, but I want to get through 3 extra problems that
Past semester. Oh,
past semesters we haven't gotten them
But
done.
we'll make up for it. The next assignment, I think, is a shorter one. So if you make it through Wednesday, Monday will be lighter.
Last semester I warned the classes. I said, you don't want to be absent on this day. We're doing rational and radical equations. It's a tough assignment.
And almost everyone's gone.
I remember that was the first time we had fewer than 10 people in both classes. And so we made the note, oh, we ain't going to tell them that beforehand. But now that you're already here, I'll tell you, this is a
Write it all spread out.
long
No, this one.
assignment, and there's a lot of tedious manipulation. Remember, let me ask you something. How many terms do we have here on number 7?
3. 1, 2, 3. So we're going to have to multiply by the least common denominator, which is what?
X minus 3.
Yeah, it's the same denominator, so x minus 3.
I wonder if there's something, I mean, in the past semesters we just, we've already done one with the same denominator. So I'm wondering maybe of what's going to happen here. When is this fraction undefined? What number could we not use as x? Positive 3. You don't want that x minus 3 to be 0. So you don't want x to be 3. So let's make a note of that. If we get 3 at the end, we're going to have to cross it out. I wonder if we're going to get a 3.
I don't know. Did the student that emailed you about it say or not? I thought you said a student
Yeah, I know.
emailed you about this.
And I said I'm going to work it in class and post a video with it worked out. It was 7 and 8 they wanted to see. And we have the same denominator, so what are we going to be multiplying through by? Just x minus 3, that denominator, x minus 3. So x minus 3 over 1, x minus 3, x minus 3 over 1.
Cancel this down.
Cancel. What have we got on the left side? Just 3x equals, here, there's no fraction to cancel. What are we going to have to do to give us 8x minus, be careful.
24.
Okay, 8 times 3 is 24. Plus, what's going to happen here? The x minus 3's cancel. And we just have a 29x squared over 1, which is a 29x squared. It's quadratic, so we need it to be set equal to 0. And we need the leading coefficient, the number in front of x squared, to be positive. So with that in mind, what do y'all think? Are we going to get the 0 on the left or on the right? On the left, okay. So we have a positive 29x squared. Let's move that 3x over and combine it with 8x. 8x minus 3x, that gives me a positive 5x. Did y'all follow me there? Minus 3 from both sides. 8x minus 3x gave me that 5x. What else do we have here? Minus 24. And the instructions that say use the quadratic formula, so I think it's factorable. 29 is nice. You've got to use 1 times 29. That's the only possibility. 24, there's quite a few. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. But I'm going to notice something. Is that what you were saying?
Yes, that's what she's. You're ahead of him.
29 minus 24, doesn't that give me 5? So that makes me think, use the 1 in 24. In the past semesters, I don't think students understood what I was trying to say. if the numbers on the outside add or subtract to give you that number in the middle, try the numbers that use 1. So I know I need a 1x and 29x, but try 1 and 24 also. So we have a 1x and a 29x. Oh, what do we know about the signs? Last sign's a minus, so we're going to have 1 of each. We'll wait to fill that in. Now, 24, I said to use a 1 and 24. I'm not going to put the 24 here. 24 times 29, I don't know what that is, but it's huge. It'd be way bigger than that 5. So try putting the 1 there and the 24 there. Inner, that gives me a 29x. Outer, what's that giving me? A 24x. And what do we need? We need a positive 5x. I couldn't hear you. Put the negative on the 24, and that means we put the positive there. I agree. That's a positive 29x then, and that's a minus 24x. 29 minus 24, yes, that gives us 5x. Set each factor equal to 0 to give us x plus 1 equals 0, and 29x minus 24 is equal to 0. What are we going to get here? Move the 1 over to give us negative 1.
Sorry, I'm already solving all the other ones.
Oh, this one here, we have a 29x equals, what are we going to have here? Positive 24. You added 24 to both sides, and then,
It's going to be 24 over 29.
okay, divide by 29 to give us x equals 24 over 29. Oh, well. Oh,
Wait,
well.
negative?
Yeah, negative 29.
No, I don't think that 29's negative.
Oh, wait, no, I'm sorry. Never mind.
Okay. You don't change the sign when you're dividing. You change the sign when you're undoing addition and
And
subtraction.
you said x couldn't be 3, so
We said x couldn't be 3. Did we get 3 as an answer?
no.
No. So these numbers are both acceptable solutions. Negative 3,
No, negative 1.
I mean negative 1 and positive 29.
Negative 1, comma, 24 over 29?
I wonder what the problem was. Why that student had the problem with this particular
I
one.
think they didn't think to use the 29 and 24 for factoring.
I'm betting that when there's something like this, when it regenerates for y'all, it'll probably give y'all messy numbers also. And so I'm betting it was something like this, the student's problem that the email referred to. I bet you in both cases they're going to have to use 1s.
Okay.
Any questions there? Radical equations. We're halfway through. How are we doing on time?
It's 3:13. You're doing really good. You're just through in an hour.
You think so?
Okay, lower. Oh,
Wait, I just... There. Radical equations.
radical is another word for those square root
also
symbols,
rational.
cube root, rationals, fractions,
Okay.
Radicals are
square roots,
cube roots for... So it's an equation. You look at an equation with square roots, cube roots, fourth roots, and so on.
If you can make it through the square root ones, the cube roots and fourth root ones are easier.
Okay. First of all, realize that we saw a rule involving square roots. I think it was on the first day of the semester. We
Well,
said...
Wait, Tim, I'm letting them see what we mean. This is a radical equation because of what?
square root symbol.
Like number 9 is a radical equation. There's that square root.
Radical does not mean bizarre or violent. It just means
Like number 11, there's a cube root in it.
so that's
And once
a
we get to
radical
that point,
equation.
it'll be all downhill. The cube roots are easier. But go ahead and I just wanted to show them what the equations look like. Go ahead.
Okay.
Rule from the first time.
We said that the square root of a, where a was any number, times the square root of a, we said that that was the same thing as the square root of a squared, and that gave us just an a. I recall a problem on your first homework. It may have been something like a square root of 3 times the square root of 3. We said, oh, that's the same as the square root of 3 squared. And that square just undoes that square root, leaving us with just a 3.
I think, in fact, on that day we actually did. The 3 times 3 is 9. Square root of 9 is 3.
I remember that now. We said
Yeah.
to multiply square roots, you keep the square root, you multiply the numbers underneath. 3 times 3 is 9. The square root of 9 is 3. That illustrates what we have here. In general, it doesn't matter what sort of a radical you're looking at. If it's an nth root, a cube root, a fourth root, or anything, if you have the nth root,
So cube root, fourth root, fifth root.
and we're going to see cube and fourth roots also, there'll be at least one of each of those in this assignment, raised to the nth power, this power will undo that radical, leaving you just the radicand, the thing that's underneath the radical. Yeah, you can think of that exponent there as canceling out that whole radical, leaving you just the radicand. So,
Does it count out the square root of 2 or just the answer?
yes, the radical, the symbol, everything. You're just left with the thing that's underneath it. We know, let's think about what we know about equations. We know that to solve an equation, whatever we do on one side, we have to do the same thing to the other side to maintain the balance. So, if we have a square root in the equation, we're going to have to square both sides. If we have a cube root, we're going to have to cube both sides. I think there's a fourth root popping up also, but we'll have to raise both sides to the fourth power. But realize you can only do that, you only cancel out the radical if the radical term is first isolated. So before you start raising both sides to a power, before raising, that's an R there, before raising both sides of an equation, to a power, you must first isolate a radical term. Now, if there's more than one radical term, you have to get one of the radicals by itself, okay? So that's why I say you must first isolate a radical. In the event there's more than one, you must first isolate a radical term. And then we can use that idea of raising both sides to a power to solve, to eliminate the radical, but there's a problem. Raising both sides of an equation to a power does not guarantee equivalence. That means that you can take an equation with the square root symbol, square both sides, and in the process, the solution you get, it may not work in the original problem. In particular, raising both sides of an equation to an even power. It's those even powers that cause problems. And why is that? Let's look at this statement here. I believe that y'all will agree with this. especially after we've talked about how negative times a negative is going to become a positive, right? That's come up before. I think you'll agree. As long as I have that even exponent on both sides, that's a true statement. Am I correct? So with the even exponents, you get a true statement. Suppose we drop off those even exponents. Is this still a true statement? It's that simple fact right there. When you're squaring both sides, or raising both sides to the fourth power, you may take something that's negative and inadvertently change it to positive. So you're going to have to check your answers when you raise both sides to an even power. You say, well, what about an odd power? If you had negative 2 cubed, is that even a true statement here? A negative to an odd power, what's that going to be? Is that becoming positive? Negative times negative is positive times negative. That's a negative 8. People don't like cube roots. They like square roots better, and I don't know why. It's the square roots that cause the problems. It's those square roots that create all those imaginary numbers. Cube roots, they don't change signs. If you take a negative number, I'm going to put a little not equal to. These odd powers, they don't change signs. If you start off with something negative, you're going to end with something negative. If you start off with something positive, you'll end with something positive. It's those even exponents that cause all the heartache for us. That's what creates complex numbers. That's what's going to create these extraneous solutions here. By the way, an extraneous solution is a solution that you think is right, but when plugged in, it doesn't actually check.
Sort of like,
we saw one. Let's see. We had an
right here. That 4.
That was an extraneous solution. It didn't actually check once we plugged it in. It gave us a denominator of 0.
Okay.
So, enough talking.
Why don't you write on it the red rule, something like...
Okay. So, red rule, you must check your answers
when working.
When raising both sides of an equation to an even power. Even, 2, 4, 6, that means if it's a square root or a fourth root or a sixth root. If it's a cube root, is 3 an odd number? I mean, an even number? No. So for cube roots, you don't have to check. So, let's see, check. I'm going to write check, square roots, and fourth roots. If you had a sixth root, you have to check that also, but I think all we have in terms of even powers are square roots and fourth roots. You don't have to check cube roots, fifth roots. Y'all understand what I'm saying there? 2, 4, 6, those are even numbers. You're going to have to check them, your answers. Cube, fifth, 3, 5, those are odd numbers. You can check them if you want to, but it's just not necessary. You're not going to create extraneous solutions.
Okay.
Any questions there?
Yeah.
And then cubes are like whatever is in there times itself times 3?
Sometimes number times itself times itself.
Right.
Mm-hmm. Okay.
Yeah.
Okay, let's see. Oh, yeah, I've written the
number
problem
8.
down. Number 8. Okay. X minus the square root of 12 minus 4x is equal to 0. I see that we have a square root, so we're going to have to square both sides.
But before you square both sides, what do you have to do?
You have to isolate a radical. In this case, there's only one radical. this thing needs to be by itself. I think the easiest way to get this square root by itself, I notice I have that minus there. I could pick up this whole thing and move it over, and what would happen to that minus?
Mm-hmm.
Okay, so I think that's the cleanest way to isolate the radical. X equals the square root of 12 minus 4x. Now, I would make a note. You're going to have to check your answers because it's a square root. I think it's easiest to check your answers in this form here, the one where the radical is isolated. You could check it in the original problem, but you'll see I have a reason for using this reduced format here. So I'm putting a little asterisk there, and I want to keep that where I can read it real clean. I don't want to make it real messy, so I'm going to recopy this whole row. X equals the square root of 12 minus 4x. I'm going to square both sides now. Square, square. I pick up an x square on the left side.
Why are we putting the square? Get rid of
The square root. The square root, you don't see a little index there. It's an assumed little 2.
You say it though, square.
I say
You
square.
don't
I
just
do.
say root. You say square root. So you assume the 2 is there.
Because most radicals that you work with are square roots, and so for brevity we don't put that little index of 2, but it's there. That's a little index of 2. What impact is the squaring going to have?
Let's just drop it.
So all we're left with is 12 minus 4x.
That's why we're squaring both sides, to cancel out that square root. Now that we have an equation we know how to solve, what kind of equation is it? Linear or quadratic? Quadratic, because there's an x squared.
We'll get this set equal to 0. Where do you think I'm going to get the 0? On the left side or the right side? The right side, because I already have that positive 1x squared. I don't want to pick this thing up and move it over, because that positive 1x squared would become a negative. I don't want a negative leading coefficient. So I'll have x squared. Move that x term over. That's going to give me a. Okay, so we have a plus 4x and. Okay, so that positive 12, we subtract 12 to get a minus 12 equals 0.
Is that going to factor pretty nicely?
Now remember, this is a nice first square root problem. I don't know why we haven't done it in the past, because this is pretty easy to factor. Put your 2 sets of parentheses. X squared is x and x. What do we know about the signs?
6 and 2? Mm-hmm. Oh.
We have a positive and negative. Choose the pair that adds or subtracts. In this case, subtracts to give us 4. How about a plus 6 and a minus 2? Does that do it? Yes. Set each factor equal to 0 to give us x equals negative 6, or here
I think they're doing it on their own, Tim. So just
so,
x equals
positive 2.
Oh.
But we have to check our answers. Okay. I'm going to check my answers.
Theoretically, both of those numbers might be solutions. Maybe only one of them will be a solution.
I will tell you this much. For a square root equation, it is extremely difficult to rig a question that has 2 extraneous solutions. If you get 2 solutions, odds favor that at least one will check. It is extremely difficult to rig the problem so that neither of the solutions check. So I'm pretty confident at least one of them is going to check.
Maybe both of them.
I'm running out of room, so I'm not going to rewrite this line right here. But this is the line that I'm checking in, where the radical is isolated. Plug in 2. Let's see what we're going to get. I'm going to do 2 first. 2 equals...
He's replacing every x with a 2 now.
the square root of 12 minus...
If you're following it, if you're caught up with this and following, what's he going to write next? When you put that 2 into for the x...
4 times 2 is...
8.
4 times 2 is 8. It's not 4 plus 2. 4 times 2 is 8. 12 minus 8 is...
You have to add,
4.
Are we getting the same number on both sides?
Does the square root of 4 equal 2? Yes, it does. So 2 checks. I remember I was the one that told Tony this trick. Check in the form where the radical is already isolated. Because I don't see a sign in front of the radical. If you don't see a sign, what sign do you assume is there, positive or negative? You assume it's positive. If you don't see a sign, it's positive. So we're plugging in negative 6. Negative 6 equals, we've already said that's a positive number there. The exact value doesn't matter. Can negative 6 equal a positive number? Can a negative equal a positive? No. So negative 6 does not work. The only number that works is positive 2. It's easier to spot those extraneous solutions when you're checking in the form where the radical is already isolated. Any questions there?
So which answer am I going to type in? Just the 2, not the negative 6. Negative 6. If you try...
can't work for that side if this is a negative.
Yeah, well,
If you plug in the negative 6, you're going to get negative 6 equals a positive square root of 12 plus 24. That's a 36. You get negative 6 equals a positive square root of 36. The square root of 36 is 6. Does negative 6 equal a positive 6? No, it doesn't. As soon as I plugged in that negative number, I knew the right side had to be positive because there was no sign. So I didn't have to go through the rest of the checking. Any questions there?
It's always gonna only be one.
nope, it could be 2.
They can both check.
They could
I'll
both
tell you what is really rare.
for
You get
both.
2 solutions and neither of them check. If that's the case, you've just messed up along the way. It is extremely rare to have 2 possible solutions, neither of which check. Okay.
Are we ready for number 9? We're going through to 14.
What did I just do?
But I'll warn you,
Is this the worst one?
I think this is the worst one. Number 9.
This is one of those.
Square roots are more involved than the cube root.
Oh.
Look at these numbers.
I know. I just saw it.
This
That's
is the
why I
worst
just
one. I think
groaned.
now I'm going to take my break, Tim.
Okay, you go right on ahead, Tony. Oh, goodness. The square root of 5x plus 9 minus 7 is equal to the binomial 3x minus 24. Okay. Let me switch over to my camera. But it's a square root, so we're going to have to square both sides, which means we're going to have to check our answers at the end. We need to get, there's only one square root symbol in this problem, so this thing needs to be by itself. What should I do to get that square root by itself? Add 7, I agree. I'll show it because this is going to get so messy. So I have just the square root of 5x plus 9 equals 3x negative 24 plus 7. Is that a negative 17? And it's the, since this is the square root, we're going to have to square both sides. So I'm going to make sure that I put a little mark here. I want to keep this thing clean because this is what I'm going to use for checking purposes. This is what I'll use. The one where the square root's already isolated. So, we have the square root of 5x plus 9 equals 3x minus 17, and we're going to square both sides. The left side works out great. What's going to happen to the left side? What are we going to get? So the square cancels out that square root, and we're just left with 5x plus 9. What are we going to have to do here? I remember a problem like this in the second homework assignment. We had two terms being squared. You keep.
Double, so 3 times 3 and then 17 times 17, right? Or no?
I couldn't hear you.
3 times 3 and then 17 times 17?
No, that's what you can't do. Write it twice in FOIL. Good. Yeah, that means you have 3x minus 17 twice. 3x minus 17 times 3x minus 17. I was jumping ahead when I groaned when I saw the numbers here. As soon as I saw that minus 24, I knew we were going to be working with some big numbers. I guess it shrank down a little bit to 17. But we're going to have to FOIL this stuff out. I'll get us started. 3x times 3x, that's a 9x squared. Outer. 3x times a negative 17. I can do that in my head. That's a minus 51x. Inner. Another minus 51x. Negative 17 times negative 17. I'm thinking that's a positive 289, but you may want to check me. Let's see, where's that calculator? There. Let's check. 17 times 17. Yep, 289. I'm reminded of those teachers at that school that they wanted to do the same problem over and over in every class so they know how to work them out. This is the stuff they didn't like the idea of. I had no control over the numbers. I knew I wanted to do this problem, but I had no control over it. But I see a 9x squared, so this is going to be quadratic. I need to get it set equal to 0. So what do you think I'm going to do? Am I going to get the 0 on the left or on the right? I'd say get it on the left because I want that 9x squared to stay positive. So, just because this is getting so messy, I'll subtract 5x. I'm going to show this. Normally I don't show that stuff at this point. And I'll minus it. Oh, heck. Thanks. Thank you. Thank you. I'm going to combine them. We're going to have to combine them. It's not whether I want to or not. I'm going to have to, whether I want to or not. So on the left side, I have just a 0. I have a 9x squared. Negative 51x minus 51x, that's a negative 102x. Minus 5x, I'm getting a minus 107x. $289 minus 9, that's going to give me what? A 280. If we had time, I would play around with this because the instructions don't say to use the quadratic formula. So I'm pretty confident this is factorable. But my goodness, 9x squared isn't that bad. 1x times 9x or 3x times 3x. But 280? Okay, 1 times 280. 2 times 140. 4 times 70. There's 10 times 28. I'm moving the prime factorizations around in my head. Let's see. I think there's too many possibilities. I'm going to the quadratic formula, okay? Let's identify A, B, and C. But I'm telling you, I bet you the number we get under the square root, when we solve this, I bet you it's going to be a perfect square. Because I think it's factorable. So I think the answers will work out real nicely if you just bear with the messy manipulation. What's A? 9. B? Negative 107, I agree. And C? 280, I agree. And we'll write down the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a.
Oh, wow. So it is messy.
And for what it's worth, if you watch the videos from last semester, number 9 is always the messiest problem in the assignment. So you can rest assured when you're doing yours, it'll be something messy like this.
But number 10 will be better.
Yeah, number 10 will be better. Negative b. Negative, we want the opposite of negative 107. What am I going to write here? Positive 107. B squared, normally I just do that in my head, you know, but no. This time I'm going to write it. Oh, you're here with the calculator. I was going to write it out.
107 squared
Is 11,449. So 11449. Can y'all read that? Is that clear? Okay. And then minus 4 times A times C. Okay. All over. Now, what is it over? 2 times 9, 18. I think I've got the factorization, okay?
I've done the square root.
Okay.
The number under the square root.
I think I've got it, okay. So,
That big number is going to be 13.
okay, so that's 13, so we have 107 plus minus the square root of 13, what is that? 1369 over 18. And what's the 1369 a perfect square? I claim it is, because this problem number 9 is always factorable. And if it's factorable, that means you can't get a square root when you're using the quadratic formula. The square root of 1369 is?
37.
37, okay.
Now this is where we separate the plus minus. Do you remember doing this in one of the problems last time?
And I made a note. I wanted to do that to, to prepare y'all. If the number under the square root is a perfect square, you can't leave your answer with a plus minus the way you do when you're stuck with a radical in the final answer. You have to split the possibilities up. So here goes. We have 107 plus 37 all over 18. That's a 144. 107 plus 7. Isn't that a 144? All over 18? Is that...
Is it divisible by 18?
I think it is.
Let's see. Oh, it is. Okay, 144 divided by 18 is 8.
Mm-hmm.
Okay. Now what about the minus?
Now let's do the minus possibility. 107 minus 37 all over 18. That's a 70 over 18, and we can cancel a 2 above and below. I'm getting 35 ninths. As I was going through the possibilities still, as I was working through this, my mind was churning, trying to figure out the 280 combination that we needed, and it hit me that it would be 35 times 8. That's what I grabbed that sheet of paper and wrote 35 on. That's the factorization that we would have needed. So I was expecting to pick up a 35 somewhere along the way. There it is.
If you put 70 over 18 into this type of calculator, it'll give you a decimal number. If you want to see that as a fraction on this type of calculator, I click Math, and that number 1 arrow fraction, that means it converts the number to a fraction, if possible. And there it is, 35 over 9. And that's stupid. Y'all can divide above and below by 2 easier than punching all of that in. But I just wanted to show y'all that key in case you did have some
messier.
Yeah.
Okay. And we have to check our work.
Oh my gosh, Tim.
We have 2 numbers. We have 8 and 35 ninths. We're going to have to plug those in.
Now, where did you write your equation?
Y'all remember? I put a little asterisk. Nope, there it is. I said that's the one that I want to use to check. Which number do you think is going to be easier to plug in? Let's start there. Which one do you think is going to... I think 8 will be easier than 35 ninths.
You write that equation so that
I'm going to. I'm going to write it right here.
Oh, okay.
The thing we're plugging into is the square root of 5x plus 9 equals 3x minus 17.
Okay, now lift up.
Okay, we're plugging into 8. That says the square root of 5 times 8 is 40 plus 9. That's the square root of 49. What's the square root of 49? 7. Are we going to get 7 on the right side? That's the question. Will the left side equal the right side? 3 times 8 is 24 minus 17. 24 minus 17, what does that equal? 7? Does 7 equal 7? Yes, it does. 8 checks. Now 35 ninths. Okay, let me rewrite the thing we're plugging in. We're plugging in the square root of 5x plus 9 equals 3x minus 17. I don't see a sign here in front of the square root. So what do we assume it is? We assume it's positive. Let's just plug in the 35 ninths
and see if it turns out to be negative.
That's right here. Let's try plugging that in. 3 times 35 ninths minus 17.
3.
Leave that calculator while I'm in my paper.
3 times 35 ninths, close parentheses,
minus 17.
Oh, we got lucky. I just love the way you say plug into that.
If you plug in where it's isolated, the right side is negative. The exact value doesn't matter. When you plug in 35 over 9, you're going to get a negative result. Well, you can cancel the 3, so that's 35 thirds minus 17. That's negative. Can the left side be negative? What sign will the left side have? What sign will the left side have?
Positive.
It's going to be positive. Can a positive equal a negative? No. 35/9 will not check.
I think a lot of times students will come up with little rules. Oh, a fraction doesn't check.
No,
that's
that
not
fraction.
what we're saying. But, oh wow.
The fact that it's a fraction is not the reason that it's not checking.
Get it put, it's all of it.
Unzoom it.
This is,
Oh, this isn't zoomed? Hold on.
but now.
Is it right?
Oh no, it's still, okay. Oh,
I can keep on moving this. I can do a manual zoom out. Okay.
he's trying to get it for the whole problem shows. Oh wow.
There it is.
Mm-hmm.
So 8 checks.
All of that
35/9.
just to get x equals 8.
Any questions there? Okay, type 8 into my lab and make sure it works.
8.
Ah. Okay. None of the others will be this long.
Yeah, so I'm an optimist. I always believe things can be worse. Now that we're through with number 9,
Things will get better now.
see, look at number 10.
Ah.
I guess you're gonna lower it or, oh wait,
Oh,
I'll
you
just
see it?
I'll just zoom it.
Okay.
Which one do y'all think is gonna be more involved? Number 9 or number 10?
Surely number 9, when I saw that minus 24, I knew we're going to wind up with some big numbers there that we're trying to
Which is once
factor.
again what those teachers were complaining about this with.
I think it's good for someone that's doing the same job as long as I have. I think those different numbers, it makes your brain work a little. I mean, we've been at this school for 32 years. I'm not going until I'm 70 at least, so
If you're able.
if I'm able to.
Okay, let me see.
So I
I'm
think
gonna
it's-
zoom in a little.
Okay. Y'all tell me it's a square root, so am I going to have to check my work? Yes, because I'm going to be squaring both sides, and 2 is an even number. I need to isolate the radical that appears. What will I do? You tell me what you think I should do.
Don't you only check it if it's an even number?
Well,
Even root.
root.
This is a square root. Don't use this 3. It's the little square root. If it's a square root,
That's
not this
when you
number.
check.
Okay? But getting to, just to make sure we're answering your question,
I get
when you look at will we have to check number 11?
Will we have look at number 11?
Look
She's looking at the.
Oh yeah, I'll forget it something. And it's because of this 3, not
That's an
that
odd
3.
number, so
Okay.
you don't check.
The root. Okay?
So going back to my question, what do y'all think I should do? I need that square root by itself. I couldn't hear you.
Square.
Before we square it, we got to get the square root by itself. Okay, move everything else over. I wouldn't want to pick this up and move it over because instead of having a square root, I didn't have a negative square root. I haven't isolated the radical. Now I have a negative in front of it. So leave that square root where it is. Move those terms over. That's going to give me the minus x will become a minus 6. Good. And here's the form I'm going to check in. So we'll square both sides now.
And you're just rewriting it so that
I want to leave
messing
that
up.
row right there clear because I need to be able to read that so I know what to plug into when I'm ready to check my answers. I'm squaring both sides. Move an arrow. It's getting in the.
Oh.
That little thing there. That doesn't seem there. The 2. The left side reduces very nicely. The square root of 3x squared, what's that going to give me? Just 3x, okay. Here, We're going to have to write it twice and FOIL it out. X minus 6 times x minus 6. First, x squared, outer. Okay, inner. Same thing. Last, negative 6 times negative 6. Okay, it's quadratic, so we need to get it set equal to 0. Do you think I'm going to get the 0 on the left side or on the right side? The left side. I don't want to move this x squared over because it'll become a negative x squared. So we have an x squared. Negative 6x minus 6x is a negative 12x. Minus 3x, what's that going to give me? Removing that 3x over, it becomes a minus 3x. Negative 15x, I agree. And I still have, and this is factorable. I already see it. Finally, we have one that's nice. That last sign's a plus, so I know something definite about the signs. What do I know? Two negatives. X squared is just 1x times 1x. 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. Nine and 12?
No. 12 and
Maybe 12 times 3. Remember, you choose here. Okay. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. You want the pair that adds together to give you 15. I agree with the 12 and the 3. And I'll leave you to check that yourself if you want to make sure that those are the correct numbers. But they are. Set each factor equal to 0. We get x minus 3 equals 0. Or x minus 12 equals 0. So here, x equals, okay, here, and we got to check. So we have 3 and 12. We're going to have to check both of them. And remember the one, I'm going to be plugging in where I have that red asterisk. I'm plugging in here. Square root of 3x equals x minus 6. Well, 3 check. 3 minus 6. 3 minus 6. What is that? Plugging in the 3 right here. Isn't that giving us a negative 3? The exact value, this value doesn't matter. What sign do we know it has? It's going to be a positive. Well, 3 times 3 is 9. So you have a positive square root of 9, which is a positive 3. But as soon as I saw we had a negative on the on the right side, but the right side had to be positive, I knew negative 3 could not check. What about 12? Plugging into the square root of 3x equals x minus 6. 3 times 12, that's 36. 12 minus 6. What's the square root of 36? What's 12 minus 6? 6. Does 6 equal 6? Yes, so 12 checked. 3 did it, 12 did.
it's very hard to rig one where there's 2 answers and
Neither of them checked. It's not that hard to rig one where there are two possible answers and they both check. I don't think that's happened today, but that can be rigged
Forgot
pretty
what the answer
easily.
is. 12?
I was about to say 6.
Oh.
Oh,
Gosh. We're doing
okay, we're doing okay. Number 11. Oh, well, I should have my little blue line. Shoot. Okay.
Oh gosh, you're thinking, oh my goodness, it's a cube root, it's going to be even worse. No, it isn't.
Cube roots get a bad rap. People
Uh-huh.
don't like them, but my goodness, they're nice.
Algebraically.
Algebraically, they're very nice.
Well, maybe if you factor the sum and difference of cubes.
Okay, sums and differences
Yeah,
of cubes
okay.
are different. I mean, okay, I can see, yeah.
But little cube root equations that we're
Okay,
going to see
switch.
today.
Okay, let's switch to my work. Ah, there we have it. This number right here, it's odd, so don't check. You can if you want to. If you just have extra time, you can check your answers, but
You don't
I don't have that extra time, so
start off by isolating the radicals.
there's
What
only
we're gonna do.
one sensible first step. What is it? Subtract 8. So we have the cube root of 3x plus 5 is equal to -1. And once you get the radical by itself, you're not going to square both sides, you'll cube both sides. So, right here, cube. This problem has to be pretty short for me to have started it down here almost at the bottom of the page, so what's the left side going to do? Okay, so the cube cancels out the cube root, and we're just left with 3x plus 5. On the right, -1 times -1 times -1, that's going to give me, it's not quadratic. We just got to get that x isolated. What will I do next? To give me 3x equals, we're minusing the 5. -1 minus 5 gives me, and then to give us x equals -2. And notice what I'm doing. It's been a while since I've done this. I just boxed it in. I didn't have to check my answer, because I didn't raise both sides to an even power. The power I was using was odd.
-2, right? Is that it? Oh, number 12 looks terrible, but it isn't. But there's a little bit of shuffling around before you start cubing both sides. What do you have to do?
Remember I said, before you raise both sides to power, you must first isolate a radical.
Here you're going to be isolating not just one radical, but 2.
Let me make sure I didn't miscopy this. Okay. Switch. We need to isolate a radical. In this case, well, let's get this one here by itself. It already has a assumed positive in front, nothing in front there. We would have to pick this second one up, move it over. What's going to happen to that sign? It's going to, so that's why, yeah, it's working out really nicely. We have a cube root of 4x squared plus 5x minus 3 equals the cube root of 6x. Once again, this thing there is odd, so no checking. Once we've isolated, we'll cube both sides. The cube root being cubed, what is that? What happens there? Okay, so we just have the radicand, 4x squared plus 5x minus 3. On the right side, 6x. It's quadratic, so we need it set equal to 0. Say it again, I couldn't hear you. Subtract 6x. You're getting the 0 on the right-hand side, and I agree. So we'll have a 4x squared. Okay, 5x minus 6x gives me a minus 1x. Minus 3 equals 0.
I just
Why?
noticed one.
What did I miss?
Yeah, we can
We move
factor.
the 6x over to get a 0 on the right-hand side. 5x minus 6x would be negative 1x. You asked, what did I just miss?
Yeah, no, I'm right, by the 6x, I was writing it, and then I don't know how you,
Oh,
Minus
move the
6x. 5x minus 6x gave us the minus 1x.
It's quadratic, so we need a 0 on one
I
side.
see, you just didn't write it.
I didn't write it, you're right.
What? Do this.
Yeah. There.
Okay, there. Is that better if I draw the arrow?
Oh, it's okay, yeah, no, I was just like, where did that number come from?
This is another one of those where I'm
Your
not going to
little rules
use my
are
little
just-
rule is really
Wow.
being applied today, and it doesn't always work. There are a few times when that isn't the case, but I think here, instead of 2x and 2x, I'm going to use 1x and 4x, because look at those terms. 4 minus 3, doesn't that equal 1? So I think we're going to need a 1x and a 4x. And now, let's see. 3 is only 1 times 3. That's all it can be. But be careful. I don't think we better put the 3 there. If we put the 3 there, that's giving us 12x. We're getting way far away. I think we better put the 1 there and the 3 there. I forgot to ask you what we know about the signs. I couldn't hear you.
Negative and then positive.
Okay, so you're being more specific. I was just going to say one of each, but you're saying to use a negative there and a positive there. I agree. That gives us a negative 4x and a positive 3x. Sure enough, that gives us the negative 1x that we need. Set each factor equal to 0. Set x plus 1 equal to
X
0.
minus 1.
X minus 1 equal to 0. And 4x plus 3 equal to 0. Here we get x equals 1. And notice I'm boxing it in. We don't have to check here. Here this says 4x is equal to negative 3, and then, okay, we divide by 4 to get x equals negative 3/4.
One and negative 3/4. 20 short years, we're going to be finished. No, actually.
I think you're
Oh,
the top
wait.
4 thirds.
Oops, sorry. Negative 3/4. Did I type it right now?
Number 13.
Okay, remember what number 12 looked like? We know how to do cube root minus cube root.
Be careful. I think. Go here.
Oh, no. Okay,
Let's
13
do
is-
number, we'll do number 14 before we do number
Yeah,
13.
okay. Here's number 14.
We'll go back to number 13. Number 14 is one of those that we haven't recorded, so I want to do that number 13.
Number 13 we haven't recorded.
And
Number 14,
number 13 is one.
I claim number 14 is actually easier than number 12, one we just did. And you might be thinking, what's missing? Is there something on this problem that you
Go
think
back
should
to
be
the
there
others.
but isn't?
Go back to the others.
I claim it's just like number 12, except it's easier. There's no x squared. Number 12 and number 14. What's different? What's missing?
Okay, there's
none of
no
those
radicals. Here's something that
you
you'll
need to
want to
know.
remember.
It's a rule of exponents that
A fractional exponent is another way of representing a radical. An exponent of 1/3 is the same thing as a cube root. The square root of a is the same thing as a to the 1/2.
wait. I'm going to write something. The cube root of a is a to the 1/3. Write the cube root and the fraction in red.
I'll let you do it. I'm not sure what you're wanting to be in red.
The cube root is the same thing as a 1/3 exponent, a 4th root is the same thing as a 1/4 exponent. You'll see what I'm writing in red? The radical is the same thing as that 1/3 exponent. So number 14, this 1/3 exponent, we could rewrite with what? Just a cube root. Okay? So if you're thinking number 14 doesn't look like number 12, oh yeah, it does. It's exactly the same type of problem. Replace this exponent here with a cube root. So here's number 14, stated with the radical symbols. I'm replacing the 1/3 exponent with a cube root. And right here I'm doing the same thing. Replace this 1/3 exponent with a cube root. And now can we go through and do exactly what we did on problem number 12? I think it'll be easier because is it going to be quadratic? I don't think we're going to have a quadratic. There's no x squared on this one here. Would y'all move this over? You want to continue, Tim?
Oh, you can go.
Oh, okay. So we have the cube root. Yeah. Cube root of 2x plus 4 equals what? Is it the cube root of 6x minus 1? Y'all have gotten mighty silent. Are y'all following what I did? A 1/3 x. Well, I wrote it replacing the 1/3 with the cube root.
Yeah, there would be a negative in front of it because you would have to add.
Yes, you have to move that over. Just like up here, we moved this over, and that negative became positive. Now, cancel out the cube root by cubing both sides. And what are we going to have?
Plus 4, 6x minus 1.
Equals 6x minus 1. This is a linear equation, so all you have to do is isolate the variable. How do you want to move the stuff around? Either put all the X's on the left or on the right. There's no incorrect answer.
What did he say?
Reverse PEMDAS. I was thinking of reverse PEMDAS. Reverse FOIL, I mean.
I would put all the X's
Oh.
on the left side.
Oh, okay. I think just.
You're gonna get the variable on the left side, that's what I would do.
Oh, okay. We're just going to isolate. I'm going to do these arrows. This is a linear equation. So the 2x minus 6x is negative 4x. What number will we have on the right? Negative 1. And move the 4. Minus 4, is that negative 5?
And then divide by 4.
Okay.
Negative 4.
Divide both sides by negative 4.
Are you gonna have to check your answer?
So what are we going to have? Just a positive 5/4?
Why did we change it to an answer?
Because 2 negatives equal positive.
Negative divided by a negative gave us a positive.
But if it was just like one of
If
those,
it was
like,
1 negative, then it would stay.
So typing in 5/4 and back. Any questions there?
It's actually a little easier than number 12 because there's no x squared in it.
If you're jogging or exercising with someone and you're trying to wear them out and you want to go longer than they do, you know what to do. Like you're on the treadmill beside someone, you make them talk. I mean, that's what you do. That's a matter, I mean, it's a known fact. Talking, you're expelling so much air, you get tired. Guess what? I've been expelling so much. Oh, that sounds vulgar. I mean, nasty. Oh my! I mean, I've been, you know what I mean.
Talking so
Breath.
much,
I've been
so you're
talking
much
so much.
tired
I'm
than me.
tired. Oh goodness.
Last problem.
Last problem.
Hey, are we going to have to check it?
yes.
Oh, good, because there's an even root. But it won't be difficult.
It won't be difficult. Okay.
You written it down?
I think so.
Notice it's already with the radical by itself, so
The radical's already isolated, so what exponent are we going to put out here? 4, I agree, because it's a 4th root. Now it's even, so check, but that
it's going to be real easy to check it.
it'll be easy to check it. What's the left side going to reduce to? X minus 15. 3 times 3 times 3 times 3. 9 times 9. Is that 81?
My calculator has. Yeah, if you multiply out 4 3s, it's like multiplying
2 9s.
Yeah. So 81.
Only one step left. Add 15 to give us x equals 96. Now let's check. Oh, by the way, I did it right. The radical was already isolated, so that's the one I'm going to check in. The 4th root of x minus 15 equals 3. Plug in the 96.
My calculator's frozen up.
Will that equal 3? Oh, we can do this
I know.
without your calculator. 96 minus 15 is 81, right? Does the 4th root of 81 equal 3? What to the 4th power will give you an 81?
This one.
Is it 3?
Yeah,
Yeah, there it is.
That's how we got the 3.
That's how we got the 81.
I mean, the 81.
3 to the 4th. So
So the 4th roots aren't difficult to check.
oh, well, this 4th
Yeah, I
root,
know.
if it were something really messy,
Well,
it would be,
you know, if we started talking about everything possible, I thought we were talking about
96.
Oh, we got it done. Oh, it was
May
a
have not
long
done
one.
it well, but we did it.
Yeah, we've worked
So-
every one of those. We didn't do number 15 because this isn't new material. This is quadratic formula.
Go back
okay?
to the notes.
Okay.
Just for one moment.
Uh-huh.
Thank you.
Now let's look at that. Are there any questions?
For radicals, here's something I've noticed. Square roots and fourth roots. If you only get one solution, odds favor it's going to check. It's hard to have a square root or a fourth root where you get one solution and it doesn't check. Now with fractions, you can get one solution and it gives you that denominator of 0. We saw an example like that at one of the earlier problems, but unfortunately, I felt like maybe everything I was saying was just hitting you in the face and bouncing off after the first 2 hours, but
Well, Tim, that was only 10 minutes. You believe that?
yeah, you're right.
Yeah.
It was hitting them in
Okay,
the
well,
face
y'all have a
before
good
then.
weekend.